Good evening, ladies and gentlemen. Welcome to the 1997 IEEE Honors Ceremony, and in particular, welcome to Cleveland. I am Charles Alexander, and it is my privilege to serve as the IEEE President and to be your host for this evening's ceremony. Sharing the podium with me is Joseph Perdonia, IEEE President-elect.
Thank you, Chuck. We have a very busy evening ahead, so I will simply add my welcome and tell you that I'm delighted to be with all of you for this very important event. This evening, we will recognize new IEEE Fellows and an honorary member and present the IEEE Service Awards, Corporate Recognitions, and IEEE Medals.
Assisting Joe and me in the presentations is the Secretary of the IEEE, Paul Chung. I am especially pleased to be here this evening in Cleveland, a city that has had a wonderful impact on my life. I was born a few miles from here and grew up in nearby Amherst. In fact, 4 generations of my family have lived in the Cleveland area. I'm especially pleased to have my wife, Paulette, my mother, June Alexander, my brother, James, and his wife, Sandy, their children, their daughter, Laura, their husband, Matt, their son, James, and his wonderful friend, Wendy, and my father, Charles Alexander, at least in spirit, are here with us tonight. Thank you very much. I'd also like to acknowledge the Cleveland section, which has been in existence nearly half as long as the city itself. Cleveland celebrated its bicentennial in 1996, and this year the section celebrates its 90th anniversary. We're delighted to have the section chair, William Schultz, here with us tonight. Bill, will you please stand? The Cleveland section boasts more than 1,500 members who work for such organizations as Centurion Energy, the NASA Lewis Research Center, Pickett International, Reliance Electric, and GE's Neela Park, among many others. Included in the section's long history of accomplishments and activities is a relationship with the Cleveland Orchestra. That relationship goes back more than 40 years. This year, the orchestra will publish a historical compact disc that includes recordings made in the 1950s, with help from the Cleveland section members, especially Herb Heller and the IEEE professional group on audio. The recording will include credits to the Institute and the Cleveland section. It will be a wonderful tribute to the contributions made by IEEE members to their community. This is a very exciting time for the Institute. We are progressing in our restructuring of the IEEE, and we have adopted a new slogan, Networking the World. This we do to help tell our members and prospective members and the leaders in industry and academia about the many ways in which IEEE fosters technological innovation, helps enable engineers' careers, and promotes a global community of members. This year also marks the first presentation of a new medal that recognizes exceptional contributions to signal processing. It is called the IEEE Jack S. Kilby Signal Processing Medal and is sponsored by Texas Instruments Incorporated. Jack Kilby is one of the co-founders of TI and is an IEEE Life Fellow. In 1986, he received the IEEE Medal of Honor. The Institute greatly appreciates TI's support for this award and their continuing support, which provides for IEEE programs and activities for our members worldwide.
The IEEE and its predecessor societies, the American Institute of Electrical Engineers and the Institute of Radio Engineers, have been recognizing outstanding contributions for almost a century. Through these awards, many illustrious inventors and innovators have been honored, individuals whose work has revolutionized technology. Today's IEEE Awards program provides peer recognition for contributions to electrical, electronics, and computer engineering and related disciplines. The awards program also helps increase public awareness of the accomplishments of engineers. By raising this awareness, we are cultivating an environment conducive to excellence in every phase of engineering. The IEEE's long tradition of recognizing engineering excellence continues this evening. The awards being presented here at Cleveland recognize some of the finest examples of work in our profession and the people responsible for these accomplishments. This year, we are honoring 18 individuals who come to the honor ceremony from Belgium, England, Switzerland, and the United States.
100 years ago, Joseph John Thomson announced a finding that was to have a lasting impact on society and on the engineering profession. His discovery of the electron, which he called a corpuscle of electrically charged matter, is considered one of the greatest milestones in science. It helped set the stage for today's age of technology. 150 years ago was the birth of one of our founders of our institute, Thomas Alva Edison. Few people have influenced life in the 20th century as much as Thomas Edison. His remarkable accomplishments exemplify the importance of inventiveness, industriousness, and perseverance to the development of significant new technologies. These qualities also are exemplified by the individuals we honor tonight. These engineers and scientists are truly exceptional, just like J.J. Thomson, Thomas Edison, and the many others that have made contributions of historic proportion that benefit our society and our profession. This evening, we are here to give them well-deserved recognition and to wish each one of them continued success. We are pleased to begin our ceremony by honoring the newly elected IEEE Fellows for their efforts in making our world a better place in which to work and live.
IEEE Fellows are an elite assembly. Each year, the Institute's Board of Directors elects a limited number of senior members to the grade of IEEE Fellow in recognition of their professional distinction. The number of fellows elected in any one year may not exceed 1/10 of 1% of the voting membership. In 1997, 244 members were elevated to IEEE Fellow. Several members of that distinguished group are here with us this evening.
The new fellows and their citations are listed alphabetically, beginning on page 43 of your program. By the way, I'm not asking you to read those real quick. You can read those later. As I read the names of the new fellows with us tonight, I ask that they rise and remain standing until all their names are called. Please hold your applause until the names of all these new fellows have been read. Dr. Francis X. Canning, Professor Virginio Cantoni, Professor Jose E. Franca, Dr. Hiroshi Iwai, Dr. Toshio Nishikawa, Professor Roger D. Pollard, Professor Parmood K. Varshney, Dr. Richard H. McFarland, hi Dick, Professor Mohammed Ismail. Ladies and gentlemen, would you please join me in saluting these leaders of our profession? In our audience and on our stage, there are those who were elected fellow in previous years. I'd like to ask that they also please stand. Thank you. Now I am pleased to introduce David Broadway, the IEEE Awards Board Chair, who will tell you about the Institute's award process. David?
Thank you, Chuck, and good evening, ladies and gentlemen. The Institute administers 8 categories of awards that are bestowed by the Board of Directors. These categories include the IEEE Medal of Honor, IEEE Medals, Technical Field Awards, Honorary Membership, Corporate Recognitions, Service Awards, Prize Papers, and Scholarships. The awards typically consist of gold and/or bronze medals, certificates, and honoraria. Some awards are funded by the IEEE Foundation, others by industry, and some by IEEE entities. Individual members, societies, and sections of the Institute are eligible to nominate candidates for any Institute award. Recipients are determined through a rigorous selection process. The process begins with an initial evaluation of nominations by the selection committee for the specific award. This committee then submits its recommendation to the awards board for approval, and final approval must be received from the IEEE Board of Directors. The awards to be presented this evening are described in your program on the page facing each recipient's biography. On behalf of the awards board and its committees, I would like to thank everyone who participated in the selection process and to tell you how proud we are to acknowledge the achievements of this year's recipients.
Thank you, David. I was speaking with Joe earlier tonight, and I'm sure Wally would share these sentiments, that the highlight of one's year as a president clearly is the night in which we are able to honor all these outstanding people. We will begin with the presentation of the IEEE Service Awards that were determined by the extensive candidate evaluation process David just described.
The first award is the IEEE Richard M. Emberson Award. It was established in 1986 to recognize distinguished service to the development, viability, advancement, and pursuit of the technical objectives of the IEEE. The award is named in honor of Richard M. Emberson, a highly revered and well-loved former executive director and general manager of the Institute.
The 1997 recipient of the IEEE Emberson Award is Friedolf M. Smits. Friedolf is a Life Fellow now serving on the IEEE Board of Directors as Vice President for Publication Activities. He is being presented with the award for Outstanding Service to the Institute in Technical Activities, Electronic Communications, and Publications Management and Finance. The award is sponsored by the IEEE Technical Activities Board. Friedolf retired in 1986 from AT&T Bell Labs in Allentown, Pennsylvania, where he was the director of the Integrated Circuit Support Laboratory. Since that time, he has made his IEEE volunteerism nearly a full-time job. He began his volunteer activities with the Institute in 1980 by serving on the Administrative Committee and as treasurer of the Electron Devices Society. He became a division director in 1988 and received the Society's 1994 Distinguished Service Award. Friedolf also has served in many positions within IEEE Technical Activities and IEEE Publication Activities. To name just a few, he chaired the Publications Product Council and the Electronic Information Dissemination Committee. He served as chair of the Electronic Publishing Committee of the Publications Board, and he contributed heavily to the startup of electronic publishing in the Institute. As early as 1990, he co-chaired a committee which moved the Institute to using internet electronic mail for staff and volunteers worldwide. Friedolf's work as a volunteer has helped the IEEE prepare for the future. The changes he initiated will leave a lasting legacy. Friedolf, it is truly an honor to present you with the IEEE Richard M. Emberson Award.
Thank you very much. I'm deeply honored to receive this award, particularly since it is for work which I personally do not consider work, but fun. I couldn't have done what I did without the cooperation of many other people. Fellow volunteers from different walks of life provided new insight. Friends from all over the world provided new perspectives. Last not least, it's most satisfying to see ideas turned into reality by a skilled and dedicated staff. But I also want to thank my wife for supporting me and tolerating a travel schedule to IEEE meetings, which she is firmly convinced are carefully scheduled to coincide with meetings a piano teacher needs to attend. Fortunately, this meeting is an exception, and she is here to witness me receiving this award, and thank you again very, very much for the honor.
Friedolf's absolutely right. I think anybody receiving an award tonight has got to thank their spouse, companion, or whatever, that, wow, you can't do this kind of stuff without support. The IEEE
Haraden Pratt Award was established in 1971. Haraden Pratt served the Institute as president, and he dedicated 23 consecutive years to the IEEE as a member of the board of directors, serving as director and director emeritus. The award recognizes outstanding service to the Institute and is presented annually to an individual who renders years of dedicated service to the IEEE. Nominees for this award must be either senior members or fellows of the Institute.
The 1997 recipient of the IEEE Haraden Pratt Award is Robert A. Rivers. Bob is a life fellow of the IEEE and president of EEE Incorporated in Union, New Hampshire. He is receiving the award for leadership and service in the professional and technical activities of the Institute. The award is sponsored by the IEEE Foundation. Bob's involvement with the Institute spans more than 45 years. He has served on the IEEE Board of Directors, on the boards for technical activities and educational activities. He also is one of the founders of IEEE Professional Activities and a creative leader in developing many of its programs. Among his many other activities, he was a member of the IEEE United States Activities Board and served on its Manpower Planning Committee. He also served on the U.S. Activities Task Force on Manpower Activities. Since 1988, he has published a monthly newsletter and numerous papers on engineer supply and demand, on careers, and on age discrimination in employment. He has been a member of the Institute's Long Range Planning Committee and the Ethics Review Panel. He chaired the Patent Policy Committee and now is on the Tellers Review Committee. Bob is a former president of the IEEE Microwave Theory and Techniques Society and served on the Society's Administrative Committee for 15 years. In addition, he has held many leadership positions at the local level, including Secretary and Treasurer, Vice Chair and Chair of this Society's Boston chapter. From his student days at MIT, when he served as a student branch vice chair, to his most recent activities, Bob Rivers has been an inspiration to his fellow members throughout the IEEE volunteer work. Bob, it gives me a great deal of pleasure to present you with the IEEE Haraden Pratt Award.
Thank you, Chuck. Before coming into this, I was advised that to keep my responses down to 2 minutes. And I didn't feel that that was an appropriate limitation. However, Chuck has covered the field so well that he has stolen my thunder. And I'll stick to the 2-minute response. And the first, I would like to recognize my wife, Priscilla, for her steadfast support in my engaging in activities within the IEEE since 1953. And she has actually encouraged me when I've become discouraged at making progress within the IEEE and its programs. She's the one that's kept me going and counseled me on staying with it. Then I would like to recognize my 3 children. Robert B. Rivers, please stand. Rosalind Dolly Rivers, please stand. And Lucy Whitmarsh. Now, as you well know, our children sometimes, just stay up. Our children sometimes bear the brunt of IEEE activities. And many a times I've been away on IEEE activities when I should be home on holidays, weekends, and celebrations. So I thank you for bearing with me. Now, I also want my 2 grandchildren to stand up and be recognized, William Krause and Rosalind Krause. Now, last but not least, you can sit down now. Last but not least, I'm being recognized for leadership. Well, I graduated from a high school in Massachusetts, Orange High School, and in my class was a Marjorie Muzzy. And she later married Joseph Ferreri, and they've lived most of their life not in Orange, Massachusetts, but in the Cleveland area. And they are here tonight, and I'd like Marjorie to stand and be recognized because she's the one that got me elected to my first leadership position in Orange High School as president of the student council. And last but certainly not least, I would like to thank all of my friends and supporters within the IEEE, who I've worked with for so many years. And I think that if there was a count of friends in the United States, majority of them would be right here. Thank you.
Thank you, Bob.
Established in 1985, the IEEE Corporate Innovation Recognition pays tribute to unique products and services in electrical, electronics, or computer technologies. This recognition has been awarded to such leading companies as Sony, Belcor, IBM, and Texas Instruments.
This year it is my pleasure to present the IEEE Corporate Innovation Recognition to Motorola. Motorola Incorporated in Schaumburg, Illinois. We're giving this for leadership in research, development, and deployment of high-density electronic packaging and interconnections for portable communications products. For more than 50 years, Motorola has played a leading role with advanced research and development in circuit design and packaging for portable communications equipment. The company introduced its first handheld and backpack radios during World War II. You may have seen some of those in some old movies. Since then, Motorola has continually strived to provide new and increasing portable products. In the late 1940s, Motorola introduced the handy-talkie FM radio phone, followed by low-frequency and very high-frequency pagers in the 1950s, 60s, and 70s. In the 1980s and 90s, Motorola developed smaller versions of the handy-talkie units. It also introduced fountain pen and credit card-sized pagers and combination wristwatch pagers. A little Dick Tracy stuff there, I guess. The company has miniaturized cellular telephones, first introduced in 1984, to a size that just weighs over 3 ounces and can fold up and easily fit inside of a shirt pocket. Today, Motorola is designing the system and portable subscriber units for Iridium, the global satellite wireless communications network. This is truly a global network designed to serve handheld telephones, sending voice, data, fax, or paging messages anywhere. Motorola's advances in high-density electronic packaging and interconnection have helped make electronic products available to people on the move. They have influenced the expansion of the entire electronic manufacturing industry. We are especially pleased to honor the accomplishments of this company tonight. Please join me in welcoming the recently retired chairman of the board and chief executive officer of Motorola, Mr. William Weisz.
Thank you, Chuck. Thank you very much. Motorola is indeed honored to have been given this award. Chuck mentioned the Iridium system. I'd like to tell you a little story as to how we got there. I was lucky enough to join Motorola in 1948, which was just before the semiconductor was invented, and joined a group of about 4 people in our portable communications design engineering organization. Back in those days, we made mobile telephones in very big boxes that sat in the trunk of an automobile and had very big, clunky stepping switches. But there were a group of engineers at Motorola and a group at Bell Labs who determined that you really wanted to talk person to person. And they had a vision, I glorify it by saying vision, really it was a fantasy, that sometime in the future, when a child was born, anywhere in the world, he or she would be issued a portable telephone, and a singular telephone number. And if you dial that number anywhere in the world and it rang more than 6 times without being answered, you would assume that that party was dead. That was ridiculous in the late 40s and early 50s. But the emphasis of the company, of that group of engineers, was constantly to work towards lighter and smaller and better operating cost equipment. And lo and behold, we've just put up 11 satellites, and by the end of 1998, we will have a worldwide portable communication system. So creativity and innovation has really been something that has been ingrained in all of us at the corporation, and we thank the IEEE for giving us this award.
Engineering Leadership Recognition, which honors the first president of the IEEE. The award is presented for leadership resulting in outstanding achievements, contributions, and service to technologies in electrical, electronics, and computer engineering and related disciplines. We are pleased to honor 2 individuals with the IEEE Engineering Leadership Recognition.
Our first recipient is Mr. John H. Crawford, an Intel Fellow and a Director of Microprocessor Architecture at Intel Corporation in Santa Clara, California. He is receiving this award for leadership in the development of microprocessors for the personal computer industry. John Crawford has been a major contributor to 3 generations of Intel microprocessor architecture. He was the chief architect of both the 386 and the 486 microprocessors, and he co-managed the development of the Pentium. These microprocessors are the brains of over 80% of the world's personal computers. Today, John manages the development of future microprocessor architectures. He has published several papers on compiler technology and microprocessor architecture. He is a co-author of a book entitled Programming the 386. He also holds 8 patents, and in 1995, he received the ACM IEEE Eckert-Mauchly Award for his contributions to microprocessor technology. John, the Institute is delighted to recognize you for your great achievements.
Okay, thank you very much. It's a great honor to accept this award. I'd like to also start by thanking my wife and my family for their support of me and for the time that my wife has been a chip widow in that. I'd also like to thank my father, who was able to be with me tonight, for providing the inspiration and support and encouragement to me even when I was a teenager, and trying to get me through that difficult period. Finally, I guess I'd like to thank God for giving me the opportunity to be in the center of this very exciting microprocessor revolution. It's been an amazing time. I've started participating really in 1982, and over a 10-year period, as was described, we put out 3 generations of microprocessors, really in kind of a race. We were racing along, harvesting the transistors that Moore's Law was providing for us, where we get double the number of transistors about every 2 years to make use of. And our challenge was to make the best use of those we could in designing and getting into volume manufacturing these various microprocessors. And we, the teams that I was privileged to be a leader of, managed to do this in ways that we doubled the performance of the products every 18 months. And this is something that's been just an amazing amount of development. A couple real-world examples were, for example, if we've been able to do this kind of a performance development of airplanes over the last 25 years, my flight from Silicon Valley out to Cleveland would take a matter of seconds instead of the 6 hours that it did take, which supposing I could survive it would have been a more pleasant experience, I guess. But it's just an incredible amount of technology advance, and the race and the treadmill that we've been on has just been incredible. So it's been fun, and I look forward to many more years of this, and hopefully the best is yet to come. So thanks again for the award.
Thank you, John. The second recipient is William J. Weisz, an IEEE Life Fellow and retired chairman of the board and chief executive officer of Motorola. He's being honored for engineering leadership and major contributions in two-way radio and paging systems. Bill Weisz joined Motorola in 1948 as a junior engineer in the Communications and Industrial Electronics Division. One of his initial assignments was to work on early versions of the company's FM portable radio telephone. He led the design of Motorola's first and subsequent lines of radio pagers. He was manager of the portable communications product line and became chief engineer and manager for all mobile and portable communication products. In 1961, Bill was appointed a Motorola vice president. After promotions to several other management positions, he was appointed chief executive officer in 1986. He was chairman of the board from 1993 through 1996. Bill helped lead Motorola to push technology towards smaller and lighter products with more features and richer performance. He is a champion of Six Sigma quality and helped inspire his company to reach the standards required to receive the coveted Malcolm Baldrige Quality Award. Bill, we proudly present to you the IEEE Ernst Weber Engineering Leadership Recognition.
Well, thank you again. It is a great honor, and I told you I was lucky enough to join the company very early on and just at the right time in our history, and being a part of such a fine organization. I thank you not just for me, because as you all know, a lot of people contribute to this award, all the Motorolans that I work with. And so my brief time today, I would like to thank my wife, who, not being just a supporter, but actually in the last 25 to 30 years has been an active participant in Motorola activities around the world. And it's impossible to have done the kinds of things that we've done without her. So I thank you again very much.
Thank you, Bill.
The Board of Directors elects as IEEE honorary members individuals who are not members of the Institute but have rendered meritorious service to society in one of the IEEE's fields of interest. This evening, we are proud to welcome one such person into our membership as an esteemed colleague.
Our new honorary member is Dr. Pekka J. Tarjani, Secretary General of International Telecommunication Union in Geneva. Dr. Tarjani is receiving an IEEE honorary membership for his outstanding leadership and contributions to the implementation of new working methods and structures for the ITU. The ITU is the world's largest telecommunications organization and one of the world's oldest international bodies. It was founded in 1865, and today it serves more than 186 government and 400 private sector members. Pekka Tarjani has led the ITU as Secretary General for most of the last decade, a period of tremendous change in telecommunications. His achievements include the first full-scale reorganization of the ITU since it became part of the United Nations system in 1947. Under his leadership, the ITU became the first organization in the UN system to streamline its technical activities and to modernize operations in finance, human resources, and information systems. He led the ITU to simplify its radio regulations, to accelerate the global telecommunication standards and development and approval process, and to refocus development activities on the requirements of the rapidly changing telecommunications industries. PECA helped enlarge the scope of the ITU activities to reflect the convergence of telecommunication, computer, broadcasting, and information technologies. He also helped the organization to focus on issues related to the global information infrastructure. PECA, we are privileged to welcome you as an honorary member of the IEEE.
Thank you very, very much. As a communications man, I'd like to communicate my thanks, my gratitude, appreciation, and admiration to IEEE and to all of you. By the way, do you know what IEEE means? It means inspires envy in everybody else. So it's a great honor, finally, to become a member of this great institute. From the ITU, I would like to bring two messages to you tonight. The first one is that we have to remember that 2/3 of mankind have never made a phone call. They have no access to communications. They're deprived of this basic human right. The second message is slightly more optimistic, because the convergence that Mr. President spoke of is something that has led us to multimedia, the biggest and most beautiful and the fastest growing sector of the global economy. So there is a lot of responsibility, there is a lot of potential, there is a lot of hope. So when we look into the 21st century, let's continue to work together in order to make sure that this engine of growth will really lead us to a global information society. And let's work together to make it a good global information infrastructure and society for the benefit of our children, our grandchildren, our great-grandchildren, and so on. Thank you very much.
Wonderful to have you. Thank you, PECA.
The first medal to be presented this evening is the new IEEE Jack S. Kilby Signal Processing Medal, sponsored by Texas Instruments. The medal was established in 1996 to recognize exceptional contributions to signal processing. It is being given for the first time here tonight. Signal processing is the key to the information revolution, and its significance and impact continue to grow. We are especially pleased to be able to call attention to signal processing technologies with this new award this year, as the IEEE Signal Processing Society begins celebrating its 50th anniversary.
Two individuals have been jointly awarded the 1997 Jack S. Kilby Signal Processing Medal. Dr. Ben Gold and Mr. Charles M. Rader. Both IEEE Life Fellows are being recognized for pioneering research in digital signal processing fundamentals, in speech signal processing, and for their landmark signal processing text. Charles Rader is a senior staff member of MIT's Lincoln Laboratory in Lexington, Massachusetts. And Ben Gold, who is now retired from the laboratory, also served as a senior staff member. Working together in the 1960s, Ben and Charles determined that digital technology could solve signal processing problems, particularly in speech and radar. They developed real-time signal processing computers and techniques, and the concept of digital filtering in audio technology. They proved digital technology could be applied to such diverse fields as radar, communications, sonar, seismology, and biology. Charles drove the design and construction of the Fast Digital Processor, or FDR, or FDP, excuse me. It is the first real-time computer with an architecture and an instruction set tailored for signal processing. Like other computers of the time, the FDP was very large. Under Ben Gold's leadership, a series of smaller and smaller signal processing computers were designed and built for speech processing applications. These advances laid the groundwork for commercial companies to develop modern digital signal processing chips. In 1969, the two co-wrote a landmark text entitled Digital Processing of Signals, describing the fundamentals of digital signal processing, including theory, algorithms, hardware, and software implementations. The book also covered advanced topics for speech and image processing. Both men made significant individual contributions to signal processing. In the early 1950s, Ben's work on pattern recognition led to one of the earliest devices that could automatically recognize hand-sent Morse code. This decoder was the basis for a pitch detector, which Ben developed in the late 50s and early 60s for use with speech signal coders. It is now considered an industry standard. He also taught the first course at MIT on digital signal processing. Although Ben retired from the MIT Lincoln Lab in 1988, he still teaches graduate courses on audio signal processing by humans and machines at the University of California, Berkeley. He holds numerous awards, including the IEEE Achievement Award and the IEEE Society Award from the Acoustics, Speech, and Signal Processing Society. Charles Rader contributed to the early development of the fast Fourier transform algorithm and other emerging signal processing technologies. He and a colleague developed the widely used butterfly diagram, which is now used predominantly as a basis of hardware and software design for the algorithm. After a 10-year break in the 1970s to concentrate his research on communication and satellite technology, Charles returned to the signal processing and in the mid-80s conceived the first wafer-scale adaptive interference cancellation chip that enabled satellite antennas to reject jamming. He is a past president of the IEEE Signal Processing Society. He also is a recipient of the IEEE Centennial Medal and the IEEE Technical Achievement Award. Gentlemen, I am pleased to award you both the first IEEE Jack S. Kilby Signal Processing Medal.
Well,
I'm not too good at public speaking, but I'll give it a try. Thank you, Mr. Alexander, the IEEE, my wife, of course, and all the people that were involved in this. And what I'd like to do, and this will take a lot less than 2 minutes, I hope, is pay my respects to a number of people who I personally have known as friends and as colleagues who have helped develop this field of digital signal processing with Charlie and me. Ken Stiglitz and Jim Kaiser were the people who, through personal connections or written material, first drew my attention to these ideas. Later, Al Oppenheim, Larry Rabiner, Ron Schaefer helped from the road that Charlie and I had taken to turn it into a major highway. They were followed by Tom Park, Sid Boris, Jim McClellan, Hans Schussler, Dan Dudgeon, Don Johnson, and Joe Tierney, all friends that I knew well and enjoyed exchanging ideas with. Finally, I want to pay my respects to Joe Levin and Professor Harevich from MIT. Professor Harevich, through his writings, and Joe Levin, through personal contact, acquainted me with the crucial math needed to do digital signal processing. Both tragically died prematurely. And finally, I'd like to again thank Mr. Kilby and the IEEE. Thank you.
I hadn't realized I'd have to cope with poor lighting here. It's true that Dr. Gold and I were able to make early and important contributions to the digital signal processing. I'd like to note that at that time, in the mid-60s, we were supposed to be working to improve speech bandwidth reduction techniques. And Ben and I knew that what we were learning about digital signal processing was ultimately going to be very important. But I'd like to acknowledge the support that we got from our group leaders, Paul Rosen and Dr. Erwin Lebo. They were the ones who had to answer to sponsors who were interested in better speech compression in the next year, not in digital signal processing in the next decade. At that time, I was also lucky to be invited to participate in an obscure IEEE working group, the Concept Subcommittee of the Standards Committee of IEEE's Group on Audio and Electroacoustics. They were interested in developing a meaningful standard for how to measure acoustical noise. And that subcommittee became the first outlet for professional collaboration and for dissemination of results in this newly emerging field. Over time, the group became, it's a great strength of the IEEE that it can provide that kind of outlet in a newly emerging field. Over time, the Group on Audio, Electro, and Acoustics evolved into today's Signal Processing Society, and its concept subcommittee became its most important technical committee. I guess IEEE membership has enriched my life, my professional life, much more than I ever would have expected.
Thank you, Ben, and thank you, Charles.
We will now present the IEEE John von Neumann Medal. This award, sponsored by IBM, is named for the famous mathematician who set standards for today's computer architecture. The medal is awarded for outstanding achievements in computer-related science and technology, whether they are theoretical, technological, or entrepreneurial.
The recipient is Dr. Maurice V. Wilkes, Staff Advisor on Research Strategy for the Olivetti and Oracle Research Laboratory in Cambridge, England. He is receiving the IEEE von Neumann Medal for a lifelong career of seminal contributions to computing, including the first full-scale operational stored program computer, and to the foundations of programming. Maurice Wilkes began his interest in computing in 1934 while a graduate student. At the Cambridge University Cavendish Laboratory, he conducted experimental research on the propagation of radio waves in the ionosphere. This led to his interest in tidal motion in the atmosphere and in computing methods. As head of the Cambridge Computer Laboratory after World War II, Maurice led the small team that developed the EDSAC computer, which became operational in the late 1940s. EDSAC was among the first complete stored program computer systems to be brought into use. In 1951, he and two colleagues published Preparation of Programs for an Electronic Digital Computer. This was one of the first books to appear on computer programming. At about this time, he proposed the concept of microprogramming, a system which later was widely adopted in the industry. In the mid-70s, Maurice studied local area networks and the use of the computer technology to increase their bandwidth. His design study became known as the Cambridge Ring. It was the basis for the Cambridge Model Distributed System, a pioneering client-server system. He has published 150 papers and 8 books, and he has received many honors for his work, including the 1992 Kyoto Prize for Advanced Technology. Maurice, we proudly present to you the IEEE John von Neumann Medal.
Thank you very much. It is indeed an honor to receive this medal named for von Neumann. I knew von Neumann. He, of course, was no engineer. You only had to be driven in a car by von Neumann to realize that. And it is said that he had outstanding record of automobiles that he crashed. If I had to describe von Neumann's work, interests, of course he was a mathematician, but he was a great formalizer. He formalized quantum mechanics, and it was his good fortune to come into contact with some very able young engineers in Philadelphia, especially Preska Eckert. And they, at that time, were developing the ideas of the modern computer. Von Neumann contributed to them, and he made a formal presentation of them, much more formal, more elegant, some ways more complete than they would have done themselves. That was his contribution to the computer field. He also supported greatly in public. He had much prestige, these new ideas, clear enough to younger people, but somehow or other, you may not believe it, but older people at that time, older engineers, found some difficulty with these new ideas of the stored program computer. Von Neumann was on the side of the angels. I have had very good luck. My professional career, too, has gained much from the IEEE, in particular from the IEEE Computer Society, which I'm proud that my name should appear on their current list of active volunteers. But I've been lucky in many ways, lucky to know von Neumann, lucky to be in the computer field in the early days when all was new and it was so easy to make significant advances. And
don't let him kid you. It really wasn't easy back then. Thank you very much, Maurice.
The Institute awards the IEEE Heinrich Hertz Medal to recognize outstanding achievements in Hertzian waves. It was established in 1987 and is presented annually for theoretical or experimental achievements.
The recipient of the IEEE Heinrich Hertz Medal is Dr. L.R. Owen Storey, retired senior research associate from the National Space Science Data Center at the NASA Goddard Space Flight Center in Greenbelt, Maryland. He is receiving the Hertz Medal for discovering the field-aligned paths of Hertzian wave whistlers generated by lightning, thus discovering the Earth's magnetosphere. In 1953 at Cambridge, Owen Storey studied the natural radio phenomena called whistling atmospherics, or better known as whistlers. At that time, whistlers were already known to be caused by the dispersion of very low-frequency radio waves from lightning strokes. He found that the propagation paths of the lightning strokes followed the lines of force of the Earth's magnetic field. This led him to discover the upward extension of the ionosphere, now known as the plasmasphere, one of the first components of the magnetosphere to be identified. Understanding this region extended several thousand kilometers beyond the Earth's surface and was critical for developing communications in space. It also helped scientists to understand how disturbances caused by radiation from the sun can cause power outages. Owen's career in research led him to positions in England, Canada, the United States, and France. And in 1963, he was appointed director for the FR1 satellite program in France, a joint project of the French National Center for Space Studies and NASA. The FR1 project studied the ionospheric and magnetospheric artificial very low-frequency radio waves from transmitters on the ground. His later projects included the development of new methods for direct measurement of the properties of space plasmas. He worked on the analysis of wave distribution function, a form of direction finding based on multi-component measurements of electromagnetic wave fields in space. In 1983, Owen joined the research faculty of the Department of Electrical Engineering at Stanford University. He also served 2 years as a visiting senior scientist at NASA headquarters in Washington, D.C., before joining the National Space Science Data Center. Please join me in welcoming Owen Storey.
Dr. Alexander, ladies and gentlemen, I thank the Institute and all concerned most warmly for this handsome award, which is particularly welcome because at the time when I did this work as a research student at the Cavendish Laboratory in Cambridge, England, it was not thought of at all highly by my peers. This was brought home to me most forcefully at one of the exhibitions that the students had to put on from time to time for the benefit of faculty and senior staff. I was called for this duty in my final year. And the way it worked was that each of us had a little stand, like in a poster session nowadays. And for us, the highlight of the proceedings was a visit by the director of the laboratory, the Cavendish professor, who would come around and hear what each student was doing and speak a few words of encouragement. Now, in those days, the Cavendish professor was Sir Lawrence Bragg, pioneer crystallographer and Nobel Prize winner. And he was rather a gruff personage, and he inspired considerable awe in us students. In our book, he was just one step down from God. And that's a very healthy attitude, by the way. I hope students still have this much respect, but I rather doubt it. Anyway, Sir Lawrence came around with his attendants, and he got to the stand next to mine. I was sort of watching him. And when I saw it, he was almost through talking with my neighbor. I straightened my tie, and I cleared my throat, and I started my vinyl disc of Whistlers playing on the phonograph, and I was about to make my little speech. Rumph! Have we got to listen to this bloody noise all afternoon? said the Cavendish professor, and he walked by to the next exhibit, leaving me wishing I could drop through the floor. So if now he's up there where we always thought he belonged, and happens to be looking down, I hope he's taking due note of these proceedings. Of these proceedings, which are balm on these ancient bruises of mine and give me the utmost satisfaction. Thank you all very much indeed.
Congratulations and thank you for your contribution. Thank you, Owen, and I'm sure your professor is smiling at this point in time.
The IEEE Richard W. Hamming Medal recognizes exceptional contributions to information science and systems. The award is funded by Lucent Technologies and is named in honor of Richard W. Hamming, who played a central role in the development of computer science and continues to be active in the field.
This year's recipient is Dr. Thomas M. Cover. He is an IEEE Fellow and a Cowtingly Professor of Engineering and also a Professor of Statistics at Stanford University. He is receiving the IEEE Hamming Medal for fundamental contributions to information and communication theory, statistics, and pattern recognition. Thomas Cover's work has had a major impact on such diverse areas as television broadcasting, high-definition television, the internet, mobile telephones, and the theory of stock market investment. In 1972, he introduced the concept of superposition in broadcast channels. This made it possible to send independent information simultaneously from one transmitter to multiple receivers. Tom also contributed to the understanding of the relative merits of code division and time division multiple access technology used in mobile telephones. In addition, he has made significant contributions to the foundation of information theory and to the relation of information theory to statistics. His early work in pattern recognition established the learning capacity of neural nets and their ability to generalize when learning ends. This laid the fundamental mathematical foundation for the field. Tom and a colleague established the factor of the two bound for the nearest neighbor rule. This rule has served for more than 20 years as a benchmark for practical pattern classification methods. In addition, he developed universal data compression algorithms for use in the stock market. Tom served as Director of Information Systems Laboratory at Stanford from 1988 to 1996. Now he leads a Stanford research group in information theory and is a professor jointly in the departments of electrical engineering and statistics. He has published more than 100 papers and has received numerous awards. These include the 1990 IEEE Claude E. Shannon Award, and the IEEE 1994 Neural Networks Counselor Pioneer Award. He is also a past president of the IEEE Information Theory Society. Ladies and gentlemen, please welcome Thomas Covert.
Well, this has been the golden age of communication and information, and I'm very pleased to receive this award. In some way, I think I'm receiving it for hundreds of people who are also working in this field, or who've either been less lucky or less sustained in their efforts. Now, with this award comes a certain responsibility, because everyone's under-recognized until they become over-recognized, and this is the line of demarcation. I think Albert Einstein put it best. He said, "Nature, in order to punish me for my disrespect for authority, has chosen to make me an authority myself." So I accept these new responsibilities. I wish to thank you very much for this honor and this award. Thank you.
Thank you, Tom.
The IEEE Medal for Engineering Excellence was established in 1986 to honor achievements of exceptional application of engineering in the technical disciplines of the IEEE for the benefit of the public and the engineering profession. The medal is funded by Siemens AG of Munich, Germany.
In case you're wondering, too, about the medals and the awards, we keep stealing them back from the recipients. They will eventually get them, but what we will be doing later on is displaying them so that you can all take a look at them. The recipient is Mr. John G. Anderson, an IEEE Life Fellow and consulting engineer in Dalton, Massachusetts. He is receiving the medal for technical contributions in engineering leadership in high voltage transmission line design and lightning protection. John joined General Electric in 1946 and soon began conducting lightning research on the Empire State Building in New York. Maybe he saw King Kong while he was there. His measurements of stroke current striking the building and high-speed photographs of the stroke processes significantly helped in the development of lightning protection of transmission lines and substations. During a long career at GE and later at Power Technologies Incorporated, John's work led to an understanding of numerous aspects of lightning protection for both transmission and distribution lines. These include transmission line insulator performances, over voltages and flashovers due to switching surges, transmission line environmental effects, lightning arrestor applications, and clearances that allow workers to work safely on energized lines. Among his many contributions are the first application of ultrasonic detection and location of lightning impulse corona and failures in transformers, special electronic equipment to measure lightning transits on transmission lines, and special computer programs to compute line lightning performance for transmission and distribution systems. John also conducted research on the mechanisms of dielectric failure of oil solid insulator structure. He later led research on the electrical characteristics of high voltage and ultra high voltage transmission lines up to 1,500 kilovolts. He has been an active member of the IEEE Power Engineering Society during his entire professional career. He received the IEEE Centennial Medal and the IEEE Halpern Award for contributions to electric power transmission engineering. Please join me in welcoming the recipient of the IEEE Engineering Excellence Medal, John G. Anderson.
Thank you, Chuck. And many, many thanks to all those engineers that worked with me over these years. And perhaps they should get the award as much as I should. I have to thank also, of course, the IEEE organization itself. Otherwise, I wouldn't be getting this medal. And I want to thank my wife, Avery, for putting up with my frequent absences in engineering work. This medal is somewhat of a bafflement to me. And one of my friends who said, Anderson, when you heard of this, you've been having engineering fun all your life and they're giving you a medal for it? And I think he hit the essence of it, because engineering can be, and for me certainly was, fun. And it, I think, will carry me for the rest of my life. I would like also to point out that there are many, many engineers out there in the IEEE. There are over 300,000 members in the IEEE, and of that, you know, there's a great many of them are really excellent engineers. And besides giving me a medal for excellence in engineering, if I had my way, we would give each of them a medal for engineering, because there's a lot of people out there deserve it as well as I do. Chuck mentioned the Empire State Building. I got the nickname of King Kong while I was, because I did work up on the roof quite a bit, and of course that's where the Great Ape and the movie King Kong worked, swatting down airplanes. It's been a dangerous profession in some ways. If the lights go off tonight, maybe I did something wrong. But I think all in all, it's been a great pleasure, and I certainly appreciate getting the medal. Thank you all.
Thank you, John.
The IEEE Alexander Graham Bell Medal, sponsored by Lucent Technologies, may be presented each year to an individual or group of up to 3 individuals for exceptional contributions to the advancement of communication sciences and engineering. The medal was established in 1976 to mark the centennial of the invention of the telephone and to honor Alexander Graham Bell.
This evening, we are proud to honor jointly 2 IEEE Fellows with the IEEE Alexander Graham Bell Medal. They are Dr. Vinton G. Cerf, Senior Vice President of MCI Communications in Reston, Virginia, and Dr. Robert E. Kahn, President of the Corporation for National Research Initiatives, or CNRI, also in Reston. These 2 are being recognized for conceiving the Internet architecture and protocols, and for the vision and sustained leadership that led to the current Internet. Vince Cerf and Bob Kahn invented the Transmission Control Protocol Internet Protocol Suite. This is the key technical innovation that helped transform the first packet switch network into the network of networks we now call the Internet. This development laid the groundwork for many of the Internet applications used today, from the transfer of files, remote login, and electronic mail to the use of the World Wide Web for telephone, radio, and video transmission. From 1976 to 1982, Vint had a major role in managing the development of Internet-related data packet technologies at DARPA, the U.S. Department of Defense Advanced Research Projects Agency. He was also the founding president of the Internet Society and is a recognized expert in Internet design and technologies. Between positions at MCI, he was vice president of CNRI, where he conducted national research efforts on the information infrastructure technology. At MCI, he was vice president of Digital Information Services and served as chief engineer in the development of MCI Mail, one of the first commercial electronic mail services. Bob Kahn founded CNRI. He founded it in 1986 after 13 years at DARPA. CNRI was created as a not-for-profit organization to provide leadership and funding for research and development of the national information infrastructure, a term he coined. The NII now is widely known as the Information Superhighway. After starting his career at Bell Laboratories and then serving as an assistant professor of electrical engineering at MIT, Bob joined Bolt, Beranek, and Neumann. There he was responsible for the system design of the ARPANET, the first packet switch network. In 1972, he moved to DARPA, where he managed research on packet networks. He later became director of DARPA's Information Processing Techniques Office and initiated the U.S. government's billion-dollar strategic computing program. This was the largest computing research and development program ever undertaken by the federal government. Bob conceived the idea of open architecture networking, and he originated DARPA's Internet program, which he led for its first 3 years. In his recent work, he has been developing the concept of a digital object infrastructure as a key component of the NII. This concept is being used in several applications, such as the electronic copyright registration system at the Library of Congress. Both Vinton and Bob were recently named as recipients of the 1997 National Medal of Technology that will be presented by President Clinton in Washington, D.C. later this year. Bob will be accepting the IEEE award this evening, as Vint could not be with us due to a conference commitment. Please join me in recognizing the achievements of Vint Cerf and Bob Kahn, the 1997 recipients of the IEEE Alexander Graham Bell Medal.
See, on behalf of both Vint and myself, I'm delighted to accept this medal and thank the IEEE for recognizing us in this fashion. I'm particularly pleased that my wife, Patrice, could be here tonight. She's an attorney in her own right in Washington, D.C., and both a partner of mine and recently a colleague in some of this digital object infrastructure work that we've been doing. I'm also very pleased that my dad could be here with us tonight, as well as my sister and brother-in-law, who are sitting over there in the front row. The story of the Internet is actually an extremely interesting one, which does date back to the 60s with the first of the packet networks. And the idea of open architecture, which I think is at the key core of what we now know as the Internet, really came about in the 1970s. I think we haven't seen any more than the tip of the iceberg so far, but I do need to say that nothing of the scope of the Internet could possibly have happened without thousands of people around the world contributing to it, both in terms of the user community, the applications, developers, the people who build the commercial side of things, and all the people in the government who have enabled it over many, many years. I think they all deserve a very strong piece of this award in many different ways. There are two things about the timing of this particular award that I'd like to mention. One, which is important to me, is the fact that George Heilmeier could be here tonight, because when we actually initiated the Internet program at DARPA and took it from an idea into a start down the path of reality, it was George who gave us the backing and support and made it possible for us to succeed. So thank you, George. And the second thing about the timing of this whole thing was the recent announcement yesterday by the Supreme Court, which recognized the Internet as an interactive medium of expression deserving of First Amendment protection at the same level as books and newspapers. And I think that's an amazing success story in its own right. So thank you, everybody, and I'm very pleased to accept this award.
Thank you, Bob.
The IEEE Education Medal is awarded for excellence in teaching, leadership in electrical engineering, education, and contributions to the profession. The medal is sponsored by Belcor.
The recipient is David A. Hodges, an IEEE Fellow and a Daniel M. Tellup Distinguished Professor at the Department of Electrical Engineering and Computer Sciences at the University of California, Berkeley. He is receiving the medal for innovative teaching of microelectronics and pioneering education in semiconductor manufacturing. Since 1991, David Hodges has been one of the leaders of Berkeley's interdisciplinary research program on competitive semiconductor manufacturing, the first United States academic program of its kind. From July 1990 through June 1996, he served as Dean of the College of Engineering. As Dean, he stimulated changes to Berkeley's engineering program that doubled undergraduate participation in independent research projects and research. David has been active in teaching and research in microelectronics, technology, and design since 1970, when he joined the Berkeley faculty. With colleagues, he developed the school's world-renowned electrical engineering courses on bipolar and MOS digital integrated circuits. He also co-authored the textbook Analysis and Design of Digital Integrated Circuits, which has been used by more than 50,000 students in the U.S. and other countries. In addition to his teaching, David has made major research contributions in the integrated circuit design and fabrication area. In the 1960s and 70s, he explored semiconductor memories, signal processing circuits, and MOS data converters and filters. Since 1984, he has centered his work on semiconductor manufacturing systems. He has graduated 27 doctoral students and 90 master's students. David was the founding editor of the IEEE Transactions on Semiconductor Manufacturing and is a past editor of the IEEE Journal of Solid-State Circuits. Ladies and gentlemen, please join me in welcoming David Hodges, the 1997 IEEE Education Medal recipient.
Well, it's an enormous honor for me to be here tonight to accept this, particularly in view of the really distinguished group of educators that have preceded me in receiving this award. I had the good fortune, in fact, to have two of those people as mentors to the development of my own career early on, Don Peterson and Ernie Koo, and I wish they could have been here tonight with me. Unfortunately, my family was unable to join me either. On looking over the list of winners this year, though, it occurred to me that there's really a certain symbolism here that I would like to comment upon. It's a symbolism of the remarkable degree of synergy that we have in this era and in this profession among the industrial world, the academic world, the government, and the professional world as represented by the IEEE and the ITU, for instance. We live in an era of very fast changes in our profession, and I think without the quite amazing amount of good interaction reflected in the careers of the people that are with us here tonight that has produced that. Sometimes it seems rather chaotic, and that's the first observation some of my friends from overseas will make, but it does produce a remarkable rate of exchange of information and progress in a fast-changing world. It's just such a wonderful pleasure to have had a career in an era like this. Thank you very much.
Thank you, David.
The IEEE Founders Medal was established in 1952 by one of the forerunners of the IEEE, the Institute of Radio Engineers. The medal is sponsored by the IEEE Foundation. This prestigious honor recognizes outstanding contributions to the profession and to the Institute through wise and courageous leadership in the planning and administration of technical developments.
The 1997 recipient is Dr. Gordon E. Moore, a Life Fellow of the IEEE and Chairman Emeritus of Intel Corporation. He is being honored for world leadership in very large-scale integration and for pioneering contributions in integrated circuit technology. Early in his career, he served as manager of the engineering department. Fairchild produced the first commercial integrated circuit after Gordon became director of research and development in 1959. In 1968, Gordon co-founded Intel to develop and produce large-scale integrated products. Under his leadership, Intel produced the world's first microprocessor and a number of other products based on large-scale integration technology. Early on, Gordon recognized the trend that integrated circuit complexity was doubling every year. Later, he refined his observations to every 24 months as the technology evolved to very large-scale integration. This trend is known as Moore's Law. It is one of the driving principles of the semiconductor industry and helped Intel become one of the world's major corporations. Gordon has received many honors for his accomplishments, including the 1990 U.S. National Medal of Technology, the Founders Award from the National Academy of Engineering, and several IEEE awards. Please join me in honoring the recipient of the 1997 IEEE Founders Medal, Gordon Moore.
Well, I too am honored to be here tonight and thank the IEEE and the Awards Committee for bestowing this honor on me. In some respect, I think this is an award for being in the right place at the right time and having the right set of colleagues, I guess. I got in the semiconductor business just about the time the advantages of silicon were being recognized. And the company we founded, Fairchild Semiconductor, got off on the right branch of the technology to make integrated circuits. We just happened to pick the right way to go. When the idea of the integrated circuit came along, we were in the right place with the right processes. Subsequently, in founding Intel and looking for ways we can make larger circuits, we were fortunate in developing the microprocessor shortly after our first memory products came along. And the microprocessor, of course, has become ubiquitous, and you find them in your automobile, your washing machine, and as well as your PC. In fact, I even find them on my cufflinks. Some of John Crawford's product, the 386, I guess, make very good cufflinks, the ones that don't work electronically. But the extent of this technology is really hard to imagine. To try to put it in some perspective, within the precision of the estimates, we make as many transistors, the industry, every year as there are ants on Earth. Another way of looking at it is something like 10 million for every human being, and this is growing at a fairly rapid rate. 10 million this year, it'll be 15 million next year. It's an industry that has grown from something very small when I got into it to the largest manufacturing industry in the world, if we look at electronics broadly. It's really been a pleasure to be part of that. The IEEE has certainly had a major impact on this growth, and I'm honored to accept the award. Good to see you.
Thank you, Gordon.
The IEEE Foundation and the Westinghouse Foundation support the IEEE Lamme Medal, which was established in honor of the outstanding design and development engineer, Benjamin Lamme. This medal recognizes meritorious achievement in the development of electrical or electronics apparatus or systems.
The 1997 recipient of the IEEE Lamme Medal is IEEE Fellow Dr. Andre Calvaer, Professor Emeritus at Liège University in Belgium. He is being honored for outstanding contributions to the analysis of the dynamic performance of electrical power systems, including the vital role of reactive power. Andre Calvaer is a highly recognized and respected scholar in power system engineering. For nearly 4 decades, he has provided leadership in the understanding of complex problems related to the dynamic performance of electric power systems and in the development of analytical techniques for the improved design and operations of these systems. Andre's professional life has been devoted primarily to the operation of the utility grid of Belgium. Since 1947, he has been closely associated with the Coordination Office for Belgium's 3 utilities. One of his major contributions was the development of a simple model to determine the operating state of a large power system after a profound disturbance. His pioneering work in the 1980s on voltage collapse helped Belgium remedy weaknesses in its high voltage power system. Long before the use of computers, he also introduced a method to simplify calculations related to older power stations. Today, utilities in Belgium, France, and in other countries continue to use his improved load flow computation method in software developed by former colleagues at Liège. They do this to help solve complex voltage stability problems. Andre maintained his advisory role with the Belgium Electric Energy Organizations while concurrently serving as head of the Electrical Engineering Department and Dean of the Faculty of Applied Science at Liège University, where he developed a program in power systems dynamics. His research activities were a continuous interweaving between the university and industry. It is my pleasure to welcome Andre Calvaer, recipient of the 1997 IEEE Lamme Medal.
Mr. President, first of all, please accept my best thanks for your two elogious presentation. To receive the Lamme Medal and to be therefore on the same roster as the previous and the today's winners of IEEE medals is a very honorable and even formidable worldwide privilege. I never dare hope it. I feel that this award does not concern one particular contribution, but my global work of the last 20 years. Therefore, I have nothing to add to the very effective citation. Should I have the suitable time, I would have been disserting over the reasons why some individuals are recognized by their peers, while others with similar merits are never. In any case, the active conclusion is my deep and heartfelt gratitude to my unquestionable nominator and his group of referees. On this great day, I wish to express my sincere thanks to the community of Belgian electrical engineers that helped me at the beginning and during my career. In the chronological order: Émile Hermann Hubert, Louis Dehaene, incidentally a very good friend of the late Walker Sisler, an Edison medalist native of Ohio, that some people between the audience did know. François Denis, Paul Fourmarier Jr., Fernand Lacoste, and André Gauman. Finally, I wish to many young IEEE members to enjoy an enthusiastic experience like my professional life.
Wonderful.
Thank you, Andre.
The IEEE Edison Medal is jointly sponsored by Hitachi, Mitsubishi Electric, and Toshiba of Japan. It was first presented in 1909, and it is the Institute's oldest major award. The IEEE Edison Medal is unique in recognizing a career of meritorious achievement in electrical engineering, electrical science, or the electrical arts.
It is with great pleasure that I present this year's IEEE Edison Medal to Dr. Esther M. Conwell, a former chair of the IEEE Awards Board, a fellow of the IEEE, and a research fellow at Cerf Corporation in Webster, New York. We are pleased to acknowledge Esther as the first woman in the history of these annual awards to receive an IEEE medal. She is being honored for fundamental contributions to transport theory in semiconductors and organic conductors in their applications to the semiconductor, electronic, photocopying, and printing industries. Esther Conwell is one of the major contributors to the field of semiconductor electronics. Her early work at the University of Rochester with Professor Victor Weisskopf is fundamental to the technology that underlies today's semiconductor industry. This initial research aided in the development of transistors and other semiconductor devices. Early in her career at AT&T, Bell Labs, and at Sylvania and GE Laboratories, Esther studied the effect of high electric fields on electron transport in semiconductors. Esther determined that the energy added to the high fields caused electrons to become hot, and this changes their motion in ways that affect device operation. In 1969, she published High Field Transport in Semiconductors, which became a basic text in the field. Esther joined Xerox in 1972 as a principal scientist. Today, she is considered one of the company's leading technical contributors. She began her work at Xerox investigating the transport of electrons in organic conductors. These conductors are important components of xerographic copiers and electronic printers. Her recent studies on the optical property of conducting polymers show promise for light-emitting diodes, photovoltaic devices, and field effect transistors used in these same applications. In addition to her research work at Xerox, Esther is an adjunct professor of chemistry at the University of Rochester and an associate director of the university's National Science Foundation Center for Photo-Induced Charge Transfer. She's a member of the National Academy of Engineering, the National Academy of Sciences, and the American Academy of Arts and Sciences. The Institute is proud to honor her career achievements by presenting the IEEE Edison Medal to Esther Conwell.
thank you for your kind introduction. It is a humbling experience to look at the list of previous winners of this medal. I am indeed honored to join such distinguished company. It is particularly gratifying to win this award because I am old enough to remember a rather different IEEE. When I was first going to the Device Research Conference, the official conference dinner was a stag dinner. I claimed the distinction of having desegregated that dinner. It really was an event. But that was a long time ago, and things have changed a lot since then. I can testify that the IEEE has made great progress in treating women more equally. If there were a medal for progress in that respect, I would award it to the IEEE. I trust and hope that this progress will continue. Thank you.
Esther, thank you so very much. I'm so glad you were here. Thank you, Esther.
The IEEE Medal of Honor is the Institute's highest award. The first recipient was Alexander Graham Bell. More recently, recipients have included Alfred Cho of AT&T Bell Laboratories, Lafti Zada of the University of California at Berkeley, and Robert Metcalf of the International Data Group. The Medal of Honor is presented only when a candidate is identified as having made a significant contribution that is an exceptional addition to the engineering and science of concern to the Institute.
I guess what I would like to do is emphasize again that it is only awarded when we have such an individual. So if there is no individual that we identify that year, the medal is not awarded. The Institute has identified just such a candidate this year. He is Dr. George H. Heilmeier, Chair and Chief Executive Officer of Belcor in Morristown, New Jersey. He is receiving the Institute's highest award for discovery and initial development of electro-optic effects in liquid crystals. The award is sponsored by the IEEE Foundation. An IEEE Fellow, George Heilmeier began his work on various electronic and electro-optic devices when he joined RCA Laboratories. In 1966, he became head of RCA's solid-state device research. His discovery of electro-optic effects in liquid crystals was announced by RCA in 1968. This work was especially significant because it enabled the development of a low-voltage flat panel display that was light-modifying rather than light-emitting, thus requiring lower power to operate. The development of this technology helped spur much of the electronics revolution over the last 25 years. It led to the first liquid crystal displays for pocket calculators, digital watches, notebook computers, and instrumentation. Today, liquid crystal diode technology is pervasive throughout our world. Its use continues to expand with such applications as image formation on large screen video systems. George's forward-looking research did not stop with the development of electro-optic effects in liquid crystals. In fact, he went on to do what some would consider 3 additional careers. In 1970, he moved to the government as a White House fellow, working as a special assistant to the U.S. Secretary of Defense. In 1971, he was appointed Assistant Director of Defense Research and Engineering, responsible for all Department of Defense programs in electronics, computer technology, and the physical sciences. In 1975, he was named Director of DARPA, where he initiated major development efforts in stealth aircraft, space-based lasers, reconnaissance systems, and infrared technology. For these contributions, he twice received the Distinguished Department of Defense Service Medal, the highest civilian award given by the department. George left DARPA to join Texas Instruments, where he served as Senior Vice President and Chief Technical Officer responsible for all TI technical activities and strategic planning. In 1991, he began his fourth career as President of Bell Corp. He became Chairman and Chief Executive Officer in 1996. Under his leadership, Bell Corp has emerged as a market-driven for-profit communications software, engineering, and professional services business with over 800 customers worldwide. George is a past recipient of the IEEE Founders Medal and has received numerous other awards for his accomplishments. These include the Japanese Communications and Computer Prize, the U.S. National Medal of Science presented by 1991 President George Bush. Ladies and gentlemen, please join me in welcoming George Heilmeier, the recipient of the 1997 IEEE Medal of Honor.
I'd like to express my gratitude and thanks to the Foundation and the Institute for honoring me with this distinguished award. When you look at the list of past recipients, you can't help but be a little bit humbled and awed, and I certainly am both this evening. I'm the original accidental engineer. Neither my mother or father graduated from high school. I was the first Heilmeier to graduate from high school, and I wanted to major in physical education and eventually become a coach someday. Fortunately or unfortunately, as the case may be, I received a scholarship to the University of Pennsylvania, and the University of Pennsylvania, being an Ivy League school, didn't have any physical education major. This created a crisis in the family. Now, coming from a German family, you do what your father tells you to do. And my father one night said, "You will study engineering, because every place I've ever worked, engineers wear clean clothes and make lots of money." Guess which one he was right about. I did my work on liquid crystal displays when I was a very young engineer at RCA Laboratories. And at that time, Vladimir Zworykin was an honorary vice president of the laboratory and generally known as the father of television. And you can imagine my excitement one day when he called me to his office and said in his thick Russian accent, "What is all this thing that you're doing with liquid crystals?" He said, "I'm hearing that something very interesting is going on." And so I explained to him what we were doing, and I'll never forget the comment that he made when I finished. I had told him, he said, "How did you come upon this?" And I said, "I stumbled on it." And he thought for a moment, and he said, "Stumbled perhaps, but to stumble you must be moving." You know, when I reflect on my own career over the years, there's a passage that was written several thousand years ago that I've identified with practically all my life. "I returned and saw under the sun that the race is not to the swift, nor battle to the strong, neither bread to the wise, nor riches to men of understanding, nor yet favors to men of skill, but time and chance happeneth to them all." Before I leave the rostrum this evening, I'd like to pay special recognition to my wife of 36 years, Janet. Would you please stand, Jeannie? Over the years,